Hey guys, could you comment your names so I can do the register, please? Is there anybody there? Oh, good. We got some people. Cool. Right. Fifi, George, and Becca. I've lost the register. Is there anybody else here yet? There's still only got 3 of you. Am I early? Oh my god, I'm early. Sorry guys, I started the whole thing early. Yeah, that was silly. I can't even do the register yet. I'm gonna disappear for 2 minutes and come back in a minute then. Be right back. See you in a bit. Right, let's do that again. So yeah, comment your names, guys, and I will do the register. Right, Fifi, George, Becca, Roddy, Alex, Callum. Anybody else yet? Any Sophie, Caleb, Charlie, Joan, or Leo? Sophie, yep. Leo, cool. Still waiting on Caleb, Charlie, and Joan. Alright, so what we're going to do today, first of all, is you guys are going to solve these quadratics. The title for today is Complex Quadratics. Really, we're just looking at quadratics with complex roots. It's going to be easy. But could you guys start by solving those two? So I'll give you a few minutes to do that, 3 minutes maybe. So I'd like you to do it without a calculator. Solve sans calculator. Yeah, so what, 3 minutes sound good? There we go, timer is on. Cool. All right, Charlie, Caleb, I'll just swipe you guys in. If you guys could comment your answers to these quadratics, that'd be good. Oh, how is everybody? Right, so the first one, seeing as nobody's put any comments yet, I'll solve this one for you, and then hopefully you guys will have answered the second one by then. So I'm going to set this equal to 0. So x squared plus 9 is 0. So x squared is minus 9. So x is plus or minus the square root of minus 9, which we can write as x is plus or minus 3i. Right, anybody got anywhere with the second one? Right, I will solve this one as well. So I'm going to complete square. You can use quadratic formula if you like to. So x squared minus 4x plus 13 equals 0. X minus 2 squared, take 4 plus 13, 0. X minus 2 squared equals 3 minus 9. So x minus 2 is plus or minus the square root minus 9. So x equals 2 plus or minus 3i. Right, so similar idea, both of these are non-real. We've got one that's an imaginary root. And this one is a complex root. With real part and with an imaginary part. So quadratics could have both real roots, or they could have a mix of complex, or not a mix, could be real, could be imaginary, or could be complex. That's alright, I will just swipe you in then, John. Cool. So everybody say it, good. Okay, so we've got imaginary roots, complex roots. Now, there's some things we can kind of infer from this. I've just written this up because you guys are just going to be writing this down anyway. So tell me if you can't read anything here. If z, or z1, is a root of a quadratic, then the complex conjugate is also a root. So where we have complex roots involved, they are always conjugates of each other. So you saw over here on the last slide, we've got 2 plus 3i and 2 minus 3i, so those are the complex conjugates of each other, the conjugate pair. And here as well, it's not a complex conjugate, but we have plus and minus 3i. So whenever you solve a quadratic, if it's got complex roots, they will always be a conjugate pair. So, yeah, if alpha and beta, we always use alpha and beta and gamma for complex roots. So if alpha and beta are complex roots of a quadratic, we can write it like this. We can go one step further and expand this. So I'll show you guys how we did that. So I'll just rewrite this sentence then. So if alpha and beta are complex roots of a quadratic, we could say z minus alpha, z minus beta equals 0. So this is kind of factorizing those complex roots. We could then expand this to get z squared minus alpha z minus beta z plus alpha beta. We could factorize out minus z to get z squared minus z alpha plus beta plus alpha beta. And that would then give us a quadratic with real, not constants, real, what's the word I'm thinking of? With real coefficients. So a, b, and c have got to be real. So if we look at this, alpha plus beta and alpha beta, because we learned last time that z plus z star is real, and z times z star is real, having two complex roots in a quadratic, when we times them out, they will give us a real term here, alpha plus beta and alpha beta, because they are complex conjugates of each other. That's quite a lot to take in at once, but it kind of does make sense based on what we did last time. So just to summarize, we find a complex root of a quadratic. The conjugate of the complex root is also, well, it is the other root, and that's because if you kind of expand those, you see here the middle term, the b term, is alpha plus beta, and these become real, and the c term is alpha times beta, which is also real. Cool. Has anyone got any questions on that? I think the rubbish man's outside, so it's getting a bit loud. But yeah, can you guys, does that all make sense to you? Cool. I'm gonna. Can you have some more commenting, please, guys? Because I've not really heard any. Yeah. Yup. Okay. As long as Joan understands it, I guess we're all right. Okay. Next slide then. So, for example, given that alpha equals 7 plus 3i is a root with real coefficients, a root of the quadratic real coefficients, find the other root beta, hence find the quadratic, and then find alpha plus beta and alpha times beta, and interpret. So could you guys do that? I'll give you 5 minutes to give that a try. Starting from now. Comment if you need any help there. Cool. Yeah, Roddy, that looks good. Part C, we'll get through. It's a bit of a question. Okay, find the other root. Well, if one root is 7 plus 3i, the other root must be 7. Oh, that doesn't look like 7 to me. 7 minus 3i. Find the quadratic, so I'm going to times those two things together. So 7 plus 3i. Well, even. That not good on its own. Z minus 7 plus 3i. And z minus 7 minus 3i. So I'm going to times out those pairs of brackets. There you go. So that will give me z squared minus 7 minus 3i z minus 7 plus 3i z plus plus 7 plus 3i times 7 minus 3i. So that's my quadratic. I just need to expand it. Z squared. Expand this, minus 7z plus 3i z minus 7z minus 3i z plus 49 minus 21i plus 21. There's a plane flying over now. It's been the noisiest I've seen ever. Minus is plus 9. Cool. So nice long expansion. Loads of this is going to cancel. So get 7 squared z squared. The 3iz and the 3iz will cancel. The 21i and the 21i will cancel, and you can see that we're going to get left with a real quadratic. So minus 14z, and then plus 49 plus 9 is going to be 58. No, yeah, 58. Plus 58. Cool. So that's my quadratic. Okay, and then find alpha plus beta and alpha beta and interpret the results. So what it means by this is kind of a picky sort of question. So alpha plus beta, 7 plus 3i plus minus 3i. So alpha plus beta is 14. And alpha beta was it 49 plus 9, 58. So alpha plus beta, the interpretation of that is it's the, is it plus 14? Should be minus 14. No, that's fine. It's the b term in quadratic, and alpha beta is the c term in the quadratic. C term. Quadratic. Cool. So basically what we've done is prove the stuff we just did on the last slide. So we've now proved the fact that b in the quadratic is that, and we've proved that c is that. So you can learn that as a result. You can learn that in a quadratic with complex roots, we've got alpha and beta. They will become alpha plus beta is your b term. Remembering that it's a minus there, that's the only tricky bit of this. And then your c term in the quadratic is there. So if you've got one root, one complex root, you can very quickly find the quadratic. And another thing that's worth learning is these two. These will save you a lot of time. So if you've got a complex root, or complex number, a plus bi, z plus the complex conjugate z is 2a, so it's 2 times the real part. So we could say z plus z star equals 2 re of z, and z times z star is re of z squared plus plus im of z squared, but I'll just learn it with am plus b like it says above. So you don't have to learn that, but it does save you a lot of time if you do, because you can very quickly just go straight to these terms in the quadratic without really thinking about it. Just 1 squared plus c squared, and then 2a for the z plus the complex conjugate. I only seen why that is on the last slide. So the non-real bits cancel out, leaving us with 2 of the a bits, and when we times them, we get 7 times 7 squared and 3 times 3 squared, and they're added because you got minus plus, obviously square root of minus is minus 1. So that's some theory there to be learned. Cool, that's the main point of what we're doing today. We're going to do some questions on this and just kind of blitz through past questions, but really it's just getting this stuff stuck in your heads. Has anyone got any questions? And this is going to tie in, tomorrow we're going to look at applying this idea to cubics and quartics. Right, so we can go. No. Right, we've got some questions to do. So swiftly moving on. Can you guys try these two? These should be pretty easy. I reckon 5 minutes to do both of these. So you've got quadratic, find alpha and beta, find alpha plus beta, and find alpha beta. So that's probably a 4-minute question for both of those. So 4 minutes starting from now, please, guys. Cool. Right, how do you get on, guys? So, right, find the roots. So, yeah, I'm just going to complete the square, I think, on this one. Although you could kind of work backwards from the stuff we just did. I'll do a complete square. So if you guys had another method, let me know. We'll go through that as well. So z plus 1 squared minus 1 plus 26 is 0. So z plus 1 squared is minus 25. So z plus 1 is plus or minus 5i. So z is minus 1 plus or minus 5i. Okay, alpha plus beta is going to be, well, the imaginary bit will cancel out, so we're going to get minus 2 for that. And then alpha beta is going to give us a squared plus b squared, 5 squared, 25, plus 1 squared, 26. There we go. We should try this one the other way then. So we can say, for question 2, alpha plus beta, I can just look straight to wait, is there something wrong there with that last one? No, it's fine. So for this one, we could jump straight into saying alpha beta is 25. We could also say alpha plus beta is 8. So we could say beta is 8 minus alpha. So we could say alpha 8 minus alpha is 25. 8 alpha minus alpha squared. Oops. Oh, this is just going to lead us into the other quadratic, isn't it? No, it probably is just easier to do it that way then. So again, complete square on it. Z squared, or z, take 4, all squared, minus 16, plus 25 is 0. Z minus 4, all squared, equals minus 9. So z minus 4 equals plus or minus 3i. So z equals 4 plus or minus 3i. A plus b, alpha plus beta, is going to be 8, and alpha beta is going to be 16 plus 9, which is 25. You can use a quadratic equation. Yeah, you can use a quadratic equation. That's absolutely fine. You get the same thing. I just like completing the square for some reason. Cool. All right, it's going to get slightly harder for the next lot. So 4-mark question. I'll give you guys 4 minutes to do it. Fifi, yeah, z squared is a squared plus b squared, but it's not a and b from the quadratic. It's yeah, to be nice and confusing, z is a plus bi. It's that a and b, and that is not the same as ax squared plus bx plus c. Those are not the same alpha a's and b's. So yeah, it's confusing. What they mean is a squared plus b squared from your complex number, not from your quadratic equation. Hopefully that clears that up. Cool. Right. Yeah, so if 2 plus 3i is one of the roots, the other root is going to be 2 minus 3i. Find the quadratic in the form z squared plus b squared plus c. So we could expand those. We could find well, the term on the end is going to be easy enough. Right, so let's, yeah, I guess yeah, you got two options. You can expand it, or you can kind of look at it and remember what we've kind of memorized. So we'll go for expanding it. If you do want to do it the other way, you can as well, though. So 2 plus 3i. So we're going to get 4 minus 6i plus 6i plus 9. What am I doing? Keep doing that. Z minus 2 plus 3i. Z plus 2 minus 3i. That should also be a minus. Expand it. Z squared minus 2 plus 3i z minus 2 minus 3i z plus z plus 3i z minus 3i. So z squared minus 4z, and then that's going to be, what's the last bit? 4 plus 9, 13. Or if you don't want to expand it, you can just look at your 2a, then a squared plus b squared for that. Everybody okay with that? So again, you can always expand stuff, or if you want to be, make the most of what we got. Learning that the b term is 2a and the c term is a squared plus b squared might be faster, but whatever. Cool. Right, next one. This is 8 marks worth, so you're going to take a little bit longer. I'll set a timer for 8 marks. Yeah, if this is seeming easy, guys, that's good. I mean, it is. Yeah, we've been told to go quite slow, so yeah. Sorry if this is painfully slow, but yeah, we'll get through it, and you'll be really good at it. So yeah, cool. Right, back in 7 minutes. Comment if you need any help. If you get stuck, and please comment your answers as well. Hey, sorry guys. I clicked the wrong thing, so give me a second. It'll load soon. There you go. Okay, cool. Where did we get to then? There we go. Cool. All right. So part A is going to be 5 plus I. Value of P and the value of Q. Well, the value of P is going to be 10. Is it 10 or is it minus 10? 10 or minus 10? You guys tell me. I think it's minus 10. And then Q is going to be, what, 26? I think that's right. I'm just doing it in my head. Okay. Right, given... this is a separate question. So, yeah. Okay, given that Z1 is 5 minus 5 plus 4, I is one of the roots of that. What is the other root? And find the values of B and C. Well, the value of B is going to be... what will that be? That'll be... Here's minus 10. Good. So this one's going to be... B will be 10 in that case, I think. And C will be 25 plus 16. Oh, I'm tired. 35, 35, 16, 40, 41, is that? C is 41? Is it 41? Is it minus 41? No, because they're both squared, so it should be 41. I think that's it. Do you guys agree? We probably ought to show some workings there. Yeah, 10 and 41. 2. Oh, should be B, should be B minus 10. No, it should be 10. Cool. If you tired efficiently. No, I'm not that tired. I'm just a bit. It's been like I taught first and then I've taught last and then it's had an afternoon, so it's been weird. Yeah, you got that too? Cool. You want to show some workings. There's worth 4 marks, so you want to at least show B squared and then show where you've got the A's and B's and C's and stuff from. Yeah. Cool. What's next? Cool. There's not too many more of these to do, to be honest. We'll probably will finish a bit early. So, 5-mark question. I'll give you guys 5 minutes to do it. Start now. Grow a beard again. I might over the summer. I'll see how I feel. Alright, find z in the form a plus ib, so we need to divide, or if you like, think about rationalizing things. So we do this to it. And it's going to turn into 15 plus 5i over 9 plus 1, so 15 over 10 plus 5 over 10i. I wrote 10 instead of 15, 15 over 10, 3 over 2 plus 1 over 2. No vector, 1 over 2i. There we go. Okay, so that's z. Given that z is a complex root of a quadratic, find value p and the value of q. So the value of p is going to be 2 lots of 3 over 2. It's going to be negative, so that will be minus 3 for p. And q is going to be 3 over 2 squared plus 1 over 2 squared. Which gives us 5 over 2, I believe. No, that can't be right because it's an integer. What have we done wrong? A squared plus b squared. I don't know what I've done there. Do you guys agree with what I've done so far? Yeah, that's the recycling men outside. It's been such a noisy evening. Yeah, that's not getting q as an integer. What am I doing wrong? See if you guys can see what I've done wrong. Rationalize that. Yeah, added those together. Yeah, 10 on the bottom. 15 over 10, 3 over 2. 5 over 10 is a half. Yes. 3 over 2 squared plus 1 over 2 squared. 5 over 2. But it says integer, and 5 over 2 isn't an integer as far as I've ever seen it. I'm going to check the answers for this one, because maybe the answers are wrong. Yeah, if you got 5 over 2 as well. Let's have a look. Where's the book? Yeah, it should be 5 over 2. That is a misprint in the book, so well done anyone that got it right. Good job. Yeah, cool. Right. Alright, we've got 2 questions left. Well, 2 on this page, 1 on the next page, and then we're done for the day. So if you get through these fast, we'll finish early. So 8 marks worth here, so I'll give you guys 8 minutes to do them. If you all comment your answers, I'll stop the timer as soon as you've all done it. So if you want to rush through it, we can finish early. But I'm not stopping the timer until every single person has posted the answers. All right, let's go through it. So we want to find B and C. That's the timer. Want to find B and C. So B is going to be 10. And C is going to be 49 again. 25 was 16. 41. 41 was that. Oh, you guys are coming to there, yeah. Yeah, cool, nice. And second one, B is going to be -2. Yeah, you guys got that. And C is going to be 5. Yeah, cool. I mean, for 4 marks, that would not get you 4 marks. So just quickly, so we can either do it by hand or we can say B equals Z plus Z star, and then do it like that. 1 plus 2i plus 1 minus 2i equals 2. Well, Z is B is minus that, and C is Z star. So C would be, and just so you've kind of shown it, so 1 plus 2 squared. Just something like that, so you get the full marks from it. Okay, last question. 4 marks. See if you guys can find P and Q. So 4 minutes starting now. All right, let's do it. Last question of the day. I don't see any answers, guys. Maybe we'll have to give you another 13 minutes to work it out. Oh wait, is that? Oh no, those are Fifi's answers. Okay, Fifi, let's have a look. So, given that is a root to that, find P and find Q. Okay, so minus 4. We can say 4P equals 5 times 2. So 4P equals 10. So P is 10 over 4. And Q squared plus P squared equals 34. So Q squared plus 5 over 2 squared is 34. Q squared plus 25 over 4 is 34. So 34 take 25 over 4. That does something stupid out. P squared plus Q squared 34. So 34 take away 25 over 4. You get 3 for Q. I don't see how you get 3 from. Wait, what am I doing? It's not Q squared plus P squared, is it? It's 5 squared plus Q squared. Cool. Anyway, let's do that better. 5 squared plus 5 over 2 squared. So 34, take 25. Wait, what am I doing? Found P, and then Q is going to be 5 squared plus Q squared. Sorry guys, that's pretty slow. 34 take 25 is 9, square root 9 is 3, yeah, so P is 3. Could be minus 3, but because it says positive constant, P must be 3. So yeah, sorry, Q even. Q is 3. Done. Cool. Alright, yeah, well done today, guys. So tomorrow, much of the same with quadratics and quartics, and yeah, then we're pretty much done with the first chapter of Further Core. Is it Further Core? Yeah, Further Core 1. Anyway, I'll see you guys tomorrow. Bye. Fragged. What? It's dragged. It did. This topic is a little bit.